Hey, this is Mrs. Lynch. This is a short video on how to find the area of regular polygons like hexagons, pentagons, octagons, even equilateral triangles. As long as they have the same length sides and all the same interior angle sizes, then it's a regular polygon. All right, so let me turn my screen around so that you can see from the document camera. All right, so you should be able to see my paper now. So the first thing you need to find the area of a regular polygon is you need the formula. All right, and just like rectangles, trapezoids, and all our other shapes have formulas for area, so do our polygons. And it is area is equal to little a times big P divided by 2. Now it's important to know what each of those letters represent. Of course, the big A is area, just like we've used in all our other formulas. The little a stands for the apothem. And I'm going to show you where that's located and what that looks like on a picture in just a second. But that's what that stands for. The big P stands for perimeter. All right, the perimeter all around, or the distance all around the polygon. And then the divide by 2 is a constant. It's just a part of the formula. All right, let me show you a picture. Now keep in mind that I'm just freehanding this picture of a hexagon, so it's not going to be perfect. All right, and it's not too bad, but this is my picture of a hexagon. And I want to show you exactly where the apothem is located. It's kind of like a radius. It goes from the center point and is basically the length that goes from the center to the middle of one of the sides of the polygon. So in this case, I just drew it to the bottom side. That apothem will always form a 90-degree angle with the side of the polygon. All right, so that purple line that I drew in represents the apothem. Sometimes they give you the length of it. Sometimes we have to actually solve and find the length of it. So let's just do a simple example first. This will be example number 1. I'll do probably 3 quick examples. All right, in one case, they may actually tell you the length of a side of the polygon and tell you what the length of the apothem is. All right, so let's say that they said that the side length is 10 centimeters, the apothem is 7 centimeters, then you already have all the numbers that you need to find the area. It's just a matter of plugging it into this formula and then doing a little bit of calculations. So for number 1 right here, if we start with the formula and plug in some numbers, all right, the apothem length, or the little a, would be the 7. So I would plug that in for little a. I would have to find the perimeter, all right? However, I know that each side is a length of 10. So all the way around, all right, if each side is 10, and I go all the way around this hexagon, it's really just doing 10 times 6. Remember, a hexagon has 6 sides, right? And 10 times 6 gives you 60. So my perimeter is 60. I plug that in. I'm going to multiply those numbers together, and then I'm going to divide by 2 at the end. Now, I believe that 7 times 60 is 420. And then if I divide that in half, I get an area of 210. All right, so my area for this first example for the hexagon is 210. Actually, I should put my units on there, so it would be centimeters squared. Now, that's the most basic type of problem that you could do, where they already tell you the side length and they already tell you the length of the apothem. You just have to plug it in, do a little bit of calculations. All right, we're going to look at example number 2. And this one, I'm going to use a different shape polygon. Let's try a pentagon, I guess. I'm going to attempt to draw it. Those are pretty hard. All right, let me get a different color here. Okay, so a pentagon, let's see, 1, 2, 3, 4, 5. All right, I did my best. It looks kind of like a diamond, but it's 5 sides. It's a pentagon. They're supposed to all be the same length, the sides, right? And my apothem, again, I'm going to draw that in. It doesn't matter which side I pick to draw it to. Most of the time, they already have that line drawn in for you when they give you the problem. So I'm going to draw mine in right here. Remember, it forms a 90-degree angle with that side that it goes to. And I'm also going to draw in a side, a line right there, because sometimes they draw that line in also to sort of confuse you, or sometimes they even give you the length of that line. Let's say that that line is a length of 8.2. All right. And also in this problem, I'm going to go ahead and start already knowing that the length of this piece right here is going to be a length of 4. Okay, now, to find the area, we need to do area equals the apothem times the perimeter divided by 2. That's our formula, all right? Right now, I don't actually know what the length of the apothem is, so we're going to have to find it, okay? I can, however, find the length of find the perimeter right now, because I know this length is 4. That whole side of the pentagon would be a length of 8, right? Because over here would also be 4. This apothem, when I draw it down, it splits that side in half, right? So if the side length is 8, there are 5 sides in a pentagon. If I do 8 times 5, it gives me a perimeter of 40. All right, I can go ahead and plug that in already. I'm going to leave a space so I can put the apothem length there in a minute. My perimeter is 40, and then I know at the end I'll have to divide by 2. Right, now we just need the length of the apothem. Okay, this problem, it's actually not too hard to do that. We get to use a formula that we've used over and over and over again called the Pythagorean theorem. We happen to have a right triangle, right? We know the length of side C is 8.2. That's across from the 90-degree angle. All right, and the apothem is the side that we don't know, and we're going to call that side X, and plug that in to a squared plus b squared is equal to c squared. All right, so my a and my b are the X and the 4. And my side C is the 8.2 squared. All right, so I know that x squared is x squared. 4 squared is 16. And 8 squared is, oh my goodness, I didn't go get a calculator. Just a second, be right back. Okay, I'm back. All right, so 8.2, if I square it, you should, hopefully you can see that, maybe not, on the calculator. There it is. Oh, sorry, there's a glare. Okay, 8.2 squared. If I press enter, it's telling me that it is 67.24. All right, then I'm going to subtract my 16 from both sides. And I get that x squared is equal to, and when I subtract, I get 51.24. And my last step, just like any other time we do Pythagorean theorem, is to take the square root. And so you get x is equal to, and when I take the square root of 51.24, I get 7.158212067. All right, so that's really long. I'm just going to round it off to 2 decimal places. So I'm going to say 7.16. It rounds up. Okay, that length, that side x that we just found, that's our apothem, right? In the picture, this side of the triangle, side x, was the length of the apothem. So that 7.16 that I found, I get to plug right into my formula for area. Okay, right there where I left a spot, and I'm going to multiply 7.16 times the perimeter, which was 40, and then divide by 2. That's what I get once I multiplied. I divide by 2, since the formula says 2, and my final area was 143.2. On this problem, I didn't write any units to start the problem. If it doesn't have units, then don't worry about putting units. If it tells you units, then make sure you put the units at the end of your answer. All right, so we're just going to leave it as 143.2. Okay, that was kind of a medium level problem because we did have to do a little extra work instead of just plug right into the formula. It was pretty simple though, because we've done the Pythagorean theorem a lot, so it should have been, it's like a medium level regular polygon problem. All right, we're going to do one more that that's like basically the hardest type of problem that we'll do in my class. All right, that has to do with regular polygons, and it involves either using trig or 30, 60, 90, or 45, 45, 90 triangles. Now, I like to teach it using trig, and I have several videos on trig if you want to watch those to review it. I'll sort of go through it a little bit as a review while we do this problem. But if you're still struggling, either come ask me about it or check out the trig videos. All right, so I'm going to go back to, actually, I'm going to try an octagon. Let's say we have a problem where we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. That's kind of a funky looking octagon, but we're going to go with it. All right, and they've given us, I'm going to draw on the apothem. Let's say they've given us the length of the apothem, but that's all. All right, so we're going to say that the apothem is 10. Let's make it something easy. 10 feet. All right, now my goal, right, I need the apothem length and the perimeter so that I can plug them into the formula. All right, I know the apothem. I can go ahead and fill that in. It's going to be 10. All right, but I don't have the perimeter because I don't yet know what the length of any of the sides are. All right, so we're going to have to find it. Okay, and when we do this, we're going to actually use trig to find it. Now, we just did a unit on circles where we talked about at the center of a circle, but also at the center of a polygon, the angle that goes all the way around is 360 degrees. Okay, each of these polygons can be split into triangles that are all the same size, especially if your picture is drawn correctly, which mine is not. Okay, now I can find the angle at the top of that triangle I just drew in, okay, by taking 360 degrees and dividing it by how many sides are on the polygon. This is an octagon, so there's 8 sides. All right, so I'm going to do 360 divided by 8. Okay, 360 divided by 8 gives us angles that are 45 degrees. All right, at the top, right here at the top of this triangle, that angle is a 45-degree angle. All right, now, since I said we're going to do trig, all right, trig only works with right triangles. If I look at that whole triangle right there, okay, if I look at this whole triangle that I drew in right there, that's not a right triangle. However, if I cut that triangle in half and use the apothem as one of the sides of the triangles, then it is. See my 90-degree angle right there? Okay, so what I'm going to do is just pretend that we're kind of zoomed in only to that 190 right triangle right there, where the side of it is 10. Okay, we talked about how the angle at the top of this outlined in pink triangle is 45. Well, in my right triangle, though, that's only half up at the top. That's only half the angle. So I'm going to take that 45-degree angle I had and now divide it in half. All right, and that should get you 22.5 degrees. Okay, so this angle up here is 22.5 degrees. And then the side of this triangle that I want to find is actually the bottom. Because if you look on it, the bottom, if I can figure out that length, that will tell me one of the side lengths of the polygon. Okay, so we're going to call that x. When we do trig, we want to have one side that is x that we're trying to find the length of. All right, so now I have everything to set up a trig problem. Okay, remember, you can use SOHCAHTOA to look at to help you figure out which trig function you're going to use. It's either going to be sine or cosine or tangent. All right, and it depends on what sides of the triangle and where your angle is. Here's our angle, the 22.5 at the top. That means the side that's x down here is side O because it's opposite from the angle. All right, the side that's not labeled over here is side H. And we're actually don't even need that side and aren't going to use it because there's nothing, no number or X labeled on it. So I'm just going to cross it out. And the side labeled 10 is the A. All right, so in this problem, we're going to use O and A, which means we're going to use tangent. All right, so I'm going to set it up. Tan, then the angle, 22.5 degrees, equals, and for a tangent problem, the O always goes on top of the A when you write the fraction. So my X is going to go on top of A, which is 10. Okay, now once you have it set up and you solve the trig problem, you have to remember the rhymes that we talked about. In this case, X is up high on our fraction. When X is up high, you multiply. So I'm going to use my calculator to multiply 10 times the tangent of 22.5. All right, make sure that your calculator is in degree mode. See that third row down, degrees is highlighted. All right, so mine is, so I'm going to type in tan 22.5 is my angle and goes in the parentheses times 10. Enter, and that gives me 4.14. We're rounding, and we're going to just cut off all those other numbers. All right, x equals 4.14. Now, remember what x represents. This side right there, all right, of the triangle is a length of 4.14. that means all the way across that whole side of the octagon, it would be 4.14 times 2, or 4.14 plus another 4.14, right? So all together, that would give you a length of 8.28 for a side. One of the sides of the octagons is 8.28. How many sides are in an octagon? There's 8 of them. So all the way around, if they're all 8.28, do 8.28 times 8 sides, and that will give you 66.24 for the perimeter. All right, we can plug that in right here. Multiply and divide, since it's part of the formula. 66.24 times 10 is 662.4. Divided in half, because that's what the formula says to do, and you get an area of 331.2. Our units are feet squared. Now again, this is like a level 3 problem. It's the hardest type you'll probably come across, just because there's many steps and it requires you to go back and remember trig. If you need more help with these, come see me. You can watch the trig video to review some of the trig stuff, or even just rewind and go through the problem again until the steps are kind of stuck in your head. Most problems are going to use tangent, but not all of them. All right, so just be aware of that.